Hey everybody, it's Leaf here. Today we're going to be talking about Solidity, and we have a 7-part long tutorial here about learning the basics of Solidity. And this is really valuable to you because typically this kind of content is behind a premium course, so getting to understand this information for free is a wonderful deal for you. So all I ask is that you please like the video so that the series can be pushed out to other developers on YouTube trying to learn this information. Thanks a ton, guys, and if you're interested in blockchain, consider subscribing to my channel because that's what this channel is all about. So, what is Solidity? I made a little graphic here. So this is you, the future blockchain developer yourself. And here we have the Ethereum virtual machine. So you don't need to understand exactly how the Ethereum virtual machine works, but keep in mind that it takes care of all the transactions on the network, and it also has smart contracts that live inside the network as well. Smart contracts are basically applications that run in the blockchain, that run on the Ethereum mainnet or testnets. And that's what we write a lot of the time when we're doing blockchain development. So the Ethereum virtual machine only reads bytecode, and it's impossible for developers to develop secure contracts with just bytecode. So we have these high-level programming languages like Solidity and Viper, and obviously we'll be doing Solidity today, that the syntax looks kind of like this, and when we compile it, it turns into bytecode. Then we deploy it to the Ethereum virtual machine. That's basically uploading it. Deploying is what we call it. And once it lives on the Ethereum virtual machine, we have a front-end UI, maybe a website or a desktop application. Typically nowadays it's a website right now, but then that website makes calls to a API like Web3 or Ethers that makes calls to the Ethereum virtual machine. And that's how we get the information. So you can think of the Ethereum virtual machine kind of like a database that holds not only information, data, but also applications. Let's get into writing these Solidity contracts. So here I have a IDE called Remix, which is an online IDE for free, and you can use it yourself to write Solidity code. It's not super robust. Like if you're going to make a large project, you'd want to use a framework or something like that. But in our case, this works just fine. So let's start out writing our Solidity file. Go over here to contract section, and you can create a new Solidity file just by right-clicking on it, new file. I already did one test.sol, and I'm just going to be pasting in this line here. This is a header on every single Solidity file, basically progma Solidity, and then the versions that you want to allow the compiler to use. If you only wanted to use one version, you could do something like this. And this would only allow the compiler to compile in Solidity version 0 to 8.4. But if you wanted a range of versions, then you could specify it like I had previously. So now we'll get into starting our first contract. So to declare a contract in Solidity, the syntax is as follows. Contract, and then the name of the contract. It looks very similar to maybe creating a class in Java, or creating there's a lot of things it's very similar to. You can think of it as a class in an object-oriented language. The first thing we're going to be talking about today is going to be talking about typing in Solidity. So it's a statically typed language. So every variable is a single type, and that doesn't change. So here I have a Boolean called true or false, and we set it equal to true. Now this constant prefix here, I guess it would be, makes it so this could never change. This value could never change. Once I take away the constant, though, it can change. So we could rewrite this to false later on in our program. Another type is our integers. So we have two types of integers in Solidity. We have uints, which are unsigned integers, which are integers that do not have a minus in front of them. And then we have several categories for the amount of bytes we want to allocate to make our contracts more efficient. But if you do uint here, it just defaults to uint 265, which is 265 bytes. So this is a very, very long unsigned integer. Then we have regular integers, which just can be signed with the negative sign. So that's pretty simple, not too complex. Now let's think about another type we have. We have strings, of course. This is a typically in the past it's an array of characters, but this is a native type in Solidity. We have string basic string, and then we set it equal to hello. Now we have arrays as well. We can use an array of every single type. We have an array of strings here. And this is the first time we see this keyword here, public, but I'll talk about that in a second. And this is how you initialize it. You just set it equal to 2 strings. So now the length of string array is 2. Index 0 is high, index 1 is low. Very similar to every other programming language. All right, so now let's talk about this public keyword, because it's really important that we understand this. When you have a public keyword, that means that it is a public value on the blockchain. So anyone can view this. So let's just do something real quick. Let's compile this with, make sure we're using 0 to 8.4 on the compiler. And by the way, in Remix, if you go over to the left, the first panel is our file exploration. The second is the compiler. The third one is the deployer. So let's compile 1.test.sol. We have no errors. Now let's go over to deploy. So we can select the contract we want to deploy, and we can deploy it. Now under deployed contracts, we have this little UI here where we can interact with our values. So I just put in index 0, and let's see what it returns to us. It returns high, as expected. So that's how public works, and that's how deploying our contracts in Remix work. So if you were to deploy to a real network, it would cost actual money, actual gas, and it's actually quite expensive at the time of me making this video, so it's good that we can test it out in Remix, so we can just figure out how the smart contract works. In the next video, we're going to get more into typings, like mappings, structures, and other things that are pretty important for Solidity. So I'll see you next time.